It's hard to say exactly how much trigonometry you should know for calculus. When I took calculus for the first time, I actually took trigonometry at the same time as taking Calc 1. So, of course, I had to do a lot of work up front to understand the basics of trigonometry, just enough so I could do the calculus, but there ends up being a lot more trigonometry in Calc 2 than in Calc 1, so you can kind of get by if you're essentially learning trigonometry as you go. Now, that's a special case. I ended up becoming a math instructor, and I worked very, very hard to do calculus and trigonometry at the same time. So it's certainly recommended that you are a pro at trigonometry, and if not, you need to be working very hard at it while you take calculus to become a pro. If it doesn't catch up with you in Calc 1, it'll catch up with you in Calc 2. So the purpose of this video is to just go over a couple of the basics you need to know so that you can continue in calculus and not be completely thrown off when you see some trigonometry. Let's start with a right triangle and go all the way back to the basics. So we'll label this side the opposite. I'm just going to say OPP, opposite, for the side opposite of the angle, adjacent, ADJ for the side adjacent to the angle, and HYP for the hypotenuse. And then we can use something called SOHCAHTOA, right? You hopefully have heard of this. SOHCAHTOA, right? And what that is a reminder of what all the trig functions are based on this angle. So sine, so this SOH, sine theta is opposite over hypotenuse, opposite over hypotenuse. And cos theta is, so adjacent over hypotenuse, or HYP. And of course, then tan theta is opposite over adjacent. SOHCAHTOA. So use it all the time in trig. It's a great way to remember the various trig functions. Some other useful things to remember, and I'll just kind of do these in any order that occur to me. Sine of 0 equals 0. That's useful. And also sine of pi over 3 equals rad 3 over 2. You can deduce a lot just from these two things, and I'll go more into why that's the case. But it's useful. If you're going to remember some things, you have to remember some. And what I don't want to see is you having to keep going to the unit circle again and again and again, or to use your calculator again and again, right? Don't become addicted to your calculator when you're doing trigonometry. At this level, you need to be doing basic trig without a calculator and not having to say, oh, what's sine 0 again, and put it into a calculator. One other useful thing to remember in this process here is rad 3 over 2 is actually greater than 1/2. That's useful because these are two of the major values that come up when you evaluate the trigonometric functions at the basic angles. Okay, one of the most useful things in dealing with trigonometry is the idea of the quadrants, and all students take calculus. What do I mean by all students take calculus? Well, you say A for all. You start in the upper right-hand quadrant, quadrant 1 we'd call this, and then you go, let's see, what is that? Counterclockwise. Students take calculus. ASTC. All students take calculus. What does that tell you? Clearly, all students don't take calculus, so let's not take it too literally. But it tells you which of the trigonometric functions are greater than 0 in each of the quadrants. So in the first one, we have all the trig functions in this first quadrant are greater than 0. The second one, S, is for sine. So the sine thetas are greater than 0 in this quadrant. That means that cosine and tangent are negative. Here we have tangent in quadrant 3. Tan theta is greater than 0. And then in quadrant 4, cos theta is greater than 0. So that's one of the most useful things. Why is that so useful? Well, once you have this, you can do all your work in quadrant 1 and then use all students take calculus to figure out if your final result is positive or negative. So it's really a quick way of doing things. And I'll go through some examples shortly on what I mean by that. One more thing before we start doing calculations on the unit circle is this. This is what I used when I was in calculus. I don't use it anymore because now I've essentially internalized it so much I don't need it. But I use this little table here. It goes like this: 0, 1, 0, 1, 0, undefined. 0, -1, 0, -1, 0, undefined. What is this? So I found it pretty easy to memorize this little block of things. What is this? Well, along the top you have sine, cosine, and tangent. And vertically you have the angles 0, pi over 2, pi, and 3 pi over 2. And it tells you all the main angles for those, all the main values for those 4 major angles. And I'll do all this in radians, but just in case there's some confusion there, pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees. Also pi over 4. We'll get to pi over 4 later, but certainly get used to working in radians. Calculus, at least in most textbooks, is done almost entirely using radians as opposed to degrees. Okay, so I'm just throwing trigonometry at you, and I apologize for that, but certainly the last thing we want to do is a long, drawn-out treatise on all of trigonometry when we're really trying to do calculus. Let's talk about the unit circle. And I don't even talk about the unit circle. I just talk about one quadrant of the unit circle because you can use all students take calculus to get all the other angles using what we call reference angles. So really you just need to know the first quadrant of the unit circle. And you essentially have 3, or I guess 5 angles of interest. So you have something like this, perfect diagonal, and then something like this. Okay, so what are these angles here? Well, let's do the angles in red. You have 0, you have pi over 6, which is 30 degrees. And again, we won't use the degrees much after this. I'll just say pi over 6. You have pi over 4, which is 45 degrees. And you have pi over 3, which is 60 degrees. And you have pi over 2, which is 90 degrees. And you essentially need to know the sine and cosine of each one of these angles. At least that's enough to get you started. Now, one thing that comes up a lot in trigonometry is that cosine of the theta goes with x. And sine of the theta goes with y. Sine goes with y. They kind of rhyme. That's one way to remember it. So I'm going to label the sine and cosine of each one of these angles, but I'm going to do it as an ordered pair. And as each one of these ordered pairs goes, the first thing is going to be the cos theta. The second, I guess, term is going to be the sine theta. Let's start with 0. Degrees or radians, it's just 0. Cos of 0 is 1, and sine of 0 is 0. So that's one thing I said it was useful to remember, that sine 0 is 0. It helps you to remember this first evaluation for 0 degrees or 0 radians. And another way to think of it is cosine goes with x, sine goes with y. So when we're at 0 degrees, we're all x. So cosine is going to get everything, sine gets nothing, right? Because here, 0, it's all x. Let's jump up to 90 degrees, or pi over 2. Here we have cos of pi over 2 is 0, and sine of pi over 2 is 1. Why? Well, there's a lot of reasons why, but one way to think of it is now we're all y, and sine goes with y, so sine gets everything, and cosine gets nothing. Right? It's just a way to kind of remember it, and it's more of an intuition that you build up over time. Okay, let's go back down to pi over 6 here. Here, cosine of pi over 6 is rad 3 over 2, and sine of pi over 6 is 1/2. How did I know that? Well, we're still mostly on the x. We're more x with pi over 6 than y, right? We're not way up here going mostly y like pi over 3, Pi over 6 is still mostly in the x direction, so we expect the cosine value to be bigger because remember cos theta goes with x. And indeed, like I said before, rad 3 over 2 is bigger than 1/2. So while we're down here closer to 0, cos theta gets the bigger value. That's one way to think about it and build up some intuition about this unit circle. Let's hop over pi over 4 for now and jump up to pi over 3. Now, sine of pi over 3, cosine of pi over 3 is 1/2, and sine of pi over 3 is rad 3 over 2. So now note that the sine value is bigger, the y value is bigger, which makes sense because we're going more in the y direction. Which again is why it's important to note that rad 3 over 2 is bigger than 1/2. Okay, lastly, let's go to pi over 4. Here they are even because it's halfway between 0 and pi over 2. So we'd expect the values to be the same, and of course they are. 1 over rad 2, comma 1 over rad 2. Which is a perfectly fine way of writing it, but a lot of people don't like having irrational numbers in the denominator. Mathematically, it's perfectly fine. The way it's written right here, 1 over rad 2 is just fine, but if that bothers you, even sometimes it bothers me because I'm just not used to it, you can write this as rad 2 over 2, comma, rad 2 over 2. That's fine too. Now, there's all kinds of tricks to remember all these values. I gave you a couple of them that I use using kind of an intuitive approach. Other people use various ways of filling this out. Do whatever works for you, and the more you see trigonometry, the more you develop a system that works for you, until eventually it just becomes second nature. That's what we're going for here. But please don't just rely on your calculator all the time, especially for these main angles. Now you're probably saying, well, what about the rest of the unit circle? Well, you don't need it. Why? Because we can use reference angles. Here's what I mean by that. So here's an example. Let's do cosine of 5 pi over 6. Now you need to know where this is. Note that 6 pi over 6 is going to be all the way to 180 or pi radians. 6 pi over 6 is the same as pi. Pi is 180. So 5 pi over 6 is going to be just pi over 6 shy of that, of pi, of 180. So we'll draw it like this. So then we're really looking for this little reference angle here of pi over 6. So then we simply go to pi over 6. We know what cos of pi over 6 is because we have those values memorized. Turns out that is rad 3 over 2. And now we use all students take calculus to figure out what cos of 5 pi over 6 is. So rad 3 over 2 is the value. Now we just need to figure out the sign, S-I-G-N, and it turns out that only sine, S-I-N-E, is positive in quadrant 2. So then we know that this must be negative rad 3 over 2. So we essentially use quadrant 1 to find the value of a trig function for a specific angle, and then we use all students take calculus and reference angles to figure out if it's positive or negative. That's the main idea. Okay, some other aspects of trig that you should know is that, not sine, but how about tan? Tan theta is, of course, sine over cosine. Sine theta over cos theta. And what else in that same vein? How about secant theta is 1 over cos theta? And how about cosecant theta is 1 over sine theta? I guess this leads us to cotan theta, which you can think of this in a few different ways. How about this? 1 over tan theta, which is 1 over sine over cosine, which is really cos theta over sine theta. Okay, so those you should have at ready recall as needed. And again, I'm only going over the bare minimum because that's really all you need for calculus. And as you get tangled up with the trig in calculus, that's a great time to review it. So you kind of make the plane as you're flying it, so to speak, when you're mastering trig as you do calculus. So let's do an example. Okay, here we go. let's figure out what tan of 15 pi over 4 is. And I'm sure there are several ways to approach this. I'll share one with you, but you're more than welcome to use whatever you've learned to get this kind of expression evaluated. So what's happening here is that this is going around and around and around, right, to land at 15 pi over 4. But note that every time we hit 2 pi, we start again at the origin. So we're essentially looking for factors of 2 pi in here. So one way to think of 15 pi over 4 is 8 pi over 4, which lands us right back at 2 pi again. So this is really 2 pi. So that's all the way around 1 plus, what do we have left? 7 pi over 4. So we start and we go 8 pi over 4. It gets us right back where we started, so we forget about that. And then we'll go 7 pi over 4. Well, we know 8 pi over 4. First note that pi over 4 is 45 degrees, or pi right here. So it's the perfect diagonal. That's pi over 4. So what's 7 of them going to be? Well, we could count them off, but it might be easier to note that all the way around is 8 pi over 4, so 7 pi over 4 must be down here. Whoops. Let's start it from 0. There we go. 7 pi over 4. Okay, and then we just evaluate what tan of pi over 4 is, right? Tan of pi over 4 is always 1. Why? Well, it's sine over cosine, and for pi over 4, sine and cosine are the same. They both equal 1 over rad 2. So you should know that tan of pi over 4 is automatically 1. Again, that's something you want to have on quick recall without having to dig deep and do a bunch of mental computations or something. So then using all students take calculus to get the sine, we're down in quadrant 4, which is C, so only cosine is positive. So that means that tangent must be negative. So finally, we have our answer. It is -1. Let's do another example. Let's do sine of 16 pi over 3. Okay, so once again, we're going to be going around and around again. Well, let's see. Going around once is what? That's 2 pi. So that's 6 pi over 3. But we can go around again. Now we're at 12 pi over 3. And if we go around again, we would be at 18 pi over 3, which would be too far. So let's go to 12 pi over 3. That starts us over at 0 and go from there. So we have 16 pi over 3 is really 12 pi over 3 plus 4 pi over 3. And we know that this is equivalent to 2 pi or 0. It's actually 4 pi, which is the same as 0. So really we need to figure out what sine of 4 pi over 3 is. Okay, back to our axes, we know that 3 pi over 3 is 90 degrees. So 4 pi over 3 is about here somewhere, down here. 4 pi over 3. But again, I'm just going to use quadrant 1 to figure out what sine of pi over 3 is, and then I'll use all students take calculus to figure out what the sine, S-I-G-N, of that angle should be. Okay, back to quadrant 1 to figure out what sine of pi over 3 should be. Well, we already know that sine pi over 3 is rad 3 over 2. That's something that we should be able to pull from somewhere in the recesses of our mind. All right, if you're reaching for a calculator, I recommend working a bit more with your trigonometry so you're not doing that. Cool, now we just use all students take calculus to figure out the sine, S-I-G-N, of it. Well, only tangent is positive in quadrant 3, so sine must be negative. We already know the value is rad 3 over 2, so the answer here is negative rad 3 over 2 for sine of 16 pi over 3. Let's do an example of solving a trigonometric equation. Okay, so here we have solve cos squared theta equals 1/2 for 0 less than or equal to theta less than 2 pi. So we're limiting it to once around the unit circle there. Okay, well, I'll avoid the arc cosine and all that, or inverse cosine, and just take the square root of both sides, tack on a plus or minus, because we're taking the square root. That leaves us with cos theta equals plus or minus 1 over rad 2. Or we could write that as plus or minus rad 2 over 2, depending upon what you're most familiar with. Well, cos of pi over 4 equals positive 1 over rad 2. So what we're looking at here is essentially pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if we go any further than that, then we're beyond pi over 2, so that doesn't do us any good. So we have theta equals pi over 4, 3 pi over 4, I'm just going to list all these off, 5 pi over 4, and 7 pi over 4. And then I stop there because going any further would take us beyond 2 pi. And there we have it. Now you might be saying, why didn't you use arc cosine, or why didn't we use this or that technique for solving these trig equations? My point is, in calculus we almost never solve trig equations. So while this was super important for trigonometry, and it might be important for some other applications, it's not really that important for certainly not Calc 1. And really not Calc 2 or 3. So I'm not going to worry too much about solving trig equations, and I guess you shouldn't either at this point. Let's focus on the trig we need and mastering it as we go, as it comes up in calculus, and I don't want to go too deep into a rabbit hole of solving all these various trig equations.